bringing you the future today. This is Resetting Tomorrow. Tales from the frontiers of science, engineering, technology, and telecom.
Hello and welcome to Resetting Tomorrow. I'm your host, Hugo Milan, and today we're heading for the final frontier. I'm thrilled to welcome Christopher Jannette, CEO of Blackstar Orbital, to the show. Christopher is a technologist, entrepreneur, and space industry leader who's taking on one of the most overlooked and perhaps lucrative problems in aerospace, the future of satellite reusability. With Blackstar Orbital, he's tackling a $15 to $20 billion bottleneck in the satellite ecosystem, looking at how we can transform space operations by repurposing assets already in orbit or in procurement. But that's not all. Christopher is also working to revolutionize direct-to-consumer payloads and advocates fiercely for STEM education. He's got bold ideas about AI, quantum computing, and the technology accelerators that will shape the next century. And today, we're lucky enough to tap into that vision. So get ready to look up and think forward. Let's get started. Christopher, welcome to the show. It's great to have you here.
Thank you very much, Hugo. It's great to be here. Happy Friday.
Thank you. Well, let's start at the beginning. What drew you into the space industry? Was there a pivotal moment or an influence that launched your interest in aerospace?
You know, it's an interesting question, Hugo. There was many pivotal moments in my life. I think really, though, the pivotal moment is just how and when me and my generation happened to grow up. I was born in March 86 in the shadow of the Challenger incident. I recall a parent of mine working for ABC News having the press badges for early shuttle launches like Columbia. I recall a great memory with my pops watching Star Trek in theaters. But the thing that really, I think, drew me into the space industry from the perspective of an engineer happened around September of 1995. I happened to really love model rockets as a young kid. We used to go through the Estes catalog. We used to get all the different ones from the Alpha 5s, Big Berthas, etc. And I recall bringing my journal with me. And I wasn't much of a journaler. I didn't keep a diary. While I enjoy creative writing, more so on the backstage than up front, getting scripts done and whatnot. And I remember that September, about September 9th, filling up a page full of all the launches and all the performance metrics that as a 9-year-old I could imagine. A few years later, I'm doing, tech ed in middle school and high school, and I find myself being drawn to two stations, the model rocket construction station and the architecture station. And while we had to do the cycle, and AV, I think, was a third one, so respect to the broadcast journalists out there, it was definitely, I think, a pivotal program, had a great education. At least I'd like to believe that it was better than average up in Northern Virginia. But really, Hugo, it came down to just being drawn to the engineering, the wonder of seeing a rocket go into the sky as a young lad, and then trying new things and experimenting. So I would put the fins on backwards. I would try some new things. I would stitch them together. I'd bring them out to the ball field. And then the other students would come and follow me as we went out there to go try to launch them. Sometimes they'd corkscrew into oblivion. Sometimes it looked like they'd disappear into the sky. But I really did love that. I ended up doing Scouts engineering school and ultimately the U.S. Air Force, where, I really did feel like that was the foundation for a real aerospace, let's just call it a professional career, working as an integrated heavy avionics technician in the Air Force, working through things like ComNav, guidance and control, mission systems. It provided a really interesting foundation, which became the basis for eventually being a systems engineer. But really, I couldn't tell you, Hugo, if it was one instance. It really was a series of them, which really did lead us on this journey and finding other people who had similar experiences where we were drawn together to make some interesting things happen.
Sounds like a great journey, and it's incredible what a contribution those little Estes rockets have made, I think, to the space industry in America, the number of kids it's inspired along the way. And now you're the CEO of Blackstar Orbital. Great name, by the way. What is the mission of the company?
Absolutely. Well, the mission can be summed up pretty simple. We are redefining what a satellite can do by redefining what a satellite is. We are building reusable satellites which launch like a traditional payload and return home like a space plane. There are over 14,000 runways worldwide longer than 5,000 feet. And additionally, with advances and miniaturization of flight electronics, that means that we're seeing a new generation of companies providing what's called downmass as a service. Now, quintessentially, the dual-use technology, when you have a 2.5-meter long space plane, we're looking at a number of different use cases and modalities. Part of what our provisional patent, which is now in patent pending status, is for, involves the multimodal payload bay on a common core airframe. In layman's terms, what that means is that you essentially have the same mass-producible reentry craft with the ability to have a hot swappable, think video game cartridge-like payloads in the payload bay that you can swap out, swap back in, warehoused on Earth as needed. So Blackstar really is eclipsing the competition through this innovative platform that we have. And while there is a place for capsule technology, and we certainly encourage our colleagues in the industry to support that, there are a number of, let's just say, limiting factors with having a ballistic capsule in terms of having dynamic reentry and reflight operations.
So satellite reusability is not a term I think many folks have heard before. Can you say a little bit more about that and kind of describe physically what does this look like?
I think in order to define the solution, first we need to define the problem, Hugo. Right now, there's over $15 to $20 billion and counting. In fact, let's just go ahead and add a zero to that if we're including Starlink and Kuiper. $15 to $20 billion worth of satellites today are either on an assembly line, on a launch pad, or in the procurement process. What that means in general terms is that customers and spaceflight operators will be spending another $15 to $20 billion and counting, replacing those constellations that are effectively single-use disposable products. What I mean by that is about 5.5 years since a Starlink launches, you will see this Starlink either re-enter in the atmosphere or become derelict space junk awaiting re-entry in the atmosphere. That's a huge problem as we have more spaceflight operators currently working in low Earth orbit. It's highly congested, and when it comes to some of our Tier 1 adversaries, low Earth orbit is now hotly contested. Again, highly congested, hotly contested, low Earth orbit for the commercial industry, and now our Tier 1 adversaries operating in this particular space, that is commercial constellations, deploying their own as well. So we expect there to be about 100,000 and counting satellites by the end of the decade, and hundreds of thousands of derelict satellites or space debris that is currently posing a problem. So it's really quite simple. The value proposition is when the mission is done, we return it to Earth, we refurbish and refly.
And what is your vision in terms of the number of flights and the scale of this opportunity over time?
We see this as a constellation replacing system for at least 1/3 of the industry. We like to say we envision a future where hundreds, if not thousands, of these hypersonic space drones are operating in and returning from low Earth orbit, if not every day, then every year. We see that drone technology in many ways has redefined the art of the possible, whether it's in the battlefield or the boardroom. And Blackstar is applying these UAS best standards and practices to the spaceflight and regime, more or less.
In the same way that SpaceX has demonstrated that you can reuse launchers multiple times, you guys are taking that to the next level and demonstrating that you can reuse satellites.
That's absolutely correct. And I don't know if I mentioned this. I'm formerly with, prior to doing Blackstar Orbital, I was the lead hypergol propellants engineer for NASA's K-Please 2 contract. But before that, I was associated with the SpaceX Starship program, working in Cape Canaveral on their thermal protection system. So when it comes to reentry and reusability, SpaceX does exemplify what that looks like. They've redefined the, let's just say, entrance fee for orbit, and that is reusability. Once Starship comes online and they work out all the technical issues, I think most of us expect that this will be the curve shift technology, the curve shifting technology that this industry has waited for, which works out great for Blackstar because instead of being charged $3,000 to $7,000 a kilogram, we expect those costs to go below $500 a kilogram within a few short years of operation. And I'll tell you what, Starship would make one heck of a carrier for a system like Blackstar.
Now, you also have mentioned direct consumer payloads. What does that mean?
That's a great question. We're happy to share with you and your listeners, Hugo, that Blackstar flew a Spacebox. And man, I wish I had it with me right now. But unfortunately, it's at the International Space Station at this very moment. It flew on Axiom 4. Direct consumer payloads, or we like to call S2C, space to consumer, can be easily summed up as this. Right now, there are amazing breakthroughs and benefits happening in space, whether that's the next breakthrough material science, whether that's the next breakthrough pharmaceutical. Things arrange and are affected differently in the microgravity, high radiation environment that can be found on the space station, which means that materials may exhibit new and novel properties, which could be a benefit to people on Earth. So we partnered with a company called Ready Set Jet, based out of Southern California, an amazing team of Tony Potts and Shelony, fantastic co-founders. They have a company that's doing wellness products. They partnered with Blackstar on their beauty baton, and that is currently up on the International Space Station today, flying in a space box. The model is very simple. Just like, say, a 23andMe, you go on the website, you customize your box, we'll send you said box to your house. You can put whatever you'd like to put in it, whether it's a personal effect, wedding rings, maybe business cards, citizen science projects, university science projects, or perhaps consumables for the International Space Station astronauts themselves, in which they can place their made-in-space manufactured products directly in the box, ordered direct from the space station, flying home on either a Dragon capsule or perhaps even a Blackstar, and then that goes back in the shipping system, returned to your house. We're the only company that's right now investigating how we can bring these benefits of space to the people. And it's phenomenal. Right now, we're within hundreds of thousands, actually in the mid-hundreds of thousands of initial impressions, hits on the Instagrams. And we're happy to say we've also partnered with the famous celebrity fashion designer, Jeff Hamilton, on some amazing custom jackets, which I actually have one if you would like to see.
I think we'd love to see that.
I may not have been able to bring the space box from Orbit, but I'd be happy to show off just the kind of brand partnerships that Blackstar has, if you will just excuse me. I think your viewers will like it. So, designer of the Kobe jacket, you can see right here, did these for us in commemoration of the Axiom 4 flight. As you can tell, we got the Black Stars right there, and of course, the space box. We are absolutely thrilled to be partnering with Jeff Hamilton on this endeavor. In fact, why don't I just put on this jacket right now to make it easier so you guys don't have to watch me putting it away. There we go. So this is the jacket by Jeff Hamilton. I suggest looking him up if you're not familiar. But again, he's very well known in multiple industries. We really are redefining, I think, the culture a little bit when it comes to Blackstar and its relation to the industry. And I'd love to give you a little bit more on that, but, I could talk about this jacket a little too long. I think you'll want to hear about satellites, perhaps. I don't know. You're the host.
Yeah, this is a fascinating vision where you're bringing things from space and making them consumer articles, and highly desirable consumer articles at that.
Hugo, it's going to get even better. One of the beauty batons, Jeff is actually going to take the materials from the in-space flown one. He's going to incorporate in the next jacket run. He'll be doing a limited run of 25 of these, if anybody's interested.
That's remarkable. Well, stepping back and putting all these pieces together, where do you see the aerospace industry in the next 10, 15 years?
And this is where we get into the serious conversation, Hugo. Right now, we're experiencing what I believe is the largest acceleration point in spacecraft, in the spacecraft manufacturing and space operations industries since really the Apollo era of the Cold War, and I'll explain why. It really comes down to compute power, the ability for smaller teams to do more. The lessons that have been learned from a commercial industry means it's a horse race. It's not just the major races of the countries trying to do prestigious mega projects. It's about market share. It's about bringing the best value to stakeholders and customers. We foresee a proliferation in constellations, per example. Right now you have Starlink. Right now you have Kuiper. You have OneWeb. I believe that now we're going to start seeing the smaller companies begin to enter this space, providing direct SAT-to-cell benefits to the customers through their own custom-made APIs. Again, now that we have artificial intelligence, the ability to provide a digital service, say software, platforms, and whatnot, will only increase. The second major trend we see is an increase in tactical satellites in orbit. We know our tier one adversaries are taking this very seriously. In fact, China right now is a space plane up. We don't see that trend going away. We see it being only more contested in low Earth orbit, as it is a finite resource in which we are quickly understanding. We also see emerging cybersecurity threats coming directly from space-based assets. Right now, there's a huge push in orbital data centers and distributed cloud compute for orbit. Two companies come to mind that perform that very well, and that's StarCloud and Phantom Space. StarCloud is taking more of a consolidated, centralized servers and orbit approach, whereas Phantom Space is focusing more on the distributed cloud compute capabilities. I believe we'll probably be seeing a trend in that. Reason being has a lot to do with bandwidth availability. right now it's fairly limited how much data you can transmit from a satellite to Earth and vice versa. There's only you'll maybe get one or two chances per pass to stay within the line of sight to downlink your data, uplink the next set of commands, and then the vehicle is more or less good to go. With on-orbit compute, what that now means is that you can perform that directly in an in-space network, get your solutions, and have those consolidated systems performing the actual link budgets between a ground station and the satellite. What this means is we're going to be seeing a projection of digital services in orbit, but really, what does that mean for everybody? Yes, we'll still have the ability to have our GPS, we'll still have our satellite internet, we'll still have our satellite radio in our cars. But one thing that isn't really talked about, and this is the quiet revolution that the United States is currently supporting, and that, of course, is the two major programs in space. That's the Artemis program and Golden Dome. With Artemis program, what we're seeing right now is the beginnings of what will be American cislunar industry in space. We see that exemplified with SpaceX and Blue Origin with their landers. Ultimately, the goal there is to set up a research base and eventually begin to offshore some of our mining capability and industrial capability to the moon. Now, we are not there yet, so in the near term, what we will see is a major push in resource and research dollars towards solving some of these problems. So when we go to the moon, there's an economic benefit related to Earth. It might come in the form of helium-3 mining if we can get fusion off the ground, but I strongly believe that with artificial intelligence, we might be refining our fusion game very quickly as soon as we make the next series of breakthroughs, which means helium-3 tends to be a more expensive option, both from an energy input standpoint as well as a acquisition standpoint. We can find helium-3 on Earth, so that might be a non-starter, but what is needed is things like steel, aluminum. Those are going to be the major things that the moon can produce, which can be used for in-space industry. And that's where you can have the price benefit for these orbital data centers, for example. Yes, we can be lifting it off the Earth, but honestly, we need to be pushing these things out to probably the Lagrange point and trying to mitigate what those latency issues are. When you're talking space to space, that latency might not matter very much. So again, why is metals manufacturing in space important when we have plenty of metal on Earth? It has to do with how things crystallize in zero-G. Again, going back to the benefits that we might find in space, I wouldn't put it past nature, and this is purely speculative on my part, that the room temperature superconducting breakthrough might have to be found in zero-G manufacturing. By just some quirk of nature and the way life works out, it might be very difficult to produce a room temperature superconductor in a one-gravity environment. We might find, and this is just highly speculative, that solution can be found in microgravity. Equally so for the next medical breakthroughs. I think we're already finding treatments for HIV, which can only be produced in space. Right now, Varda Space Industries is handling that, and they're doing an amazing job. On the topic of where we think the industry is going, right now we're seeing Varda Space on their 4th reusable capsule mission. So there's a market for this right now, today. This is not a future-forward technology. This is something that is happening and has happened. So now it's just a matter of sticking to those trend lines and being part of what could be one of the greatest revolutions since the initial industrial revolution. And we're happy to be here for it.
Very exciting future. So what advice would you give young people if they want to enter this sector?
Follow your passions, go where you feel the most useful, and just understand that there's many different elements of a space industry. Let's just say, I don't want to say employee, but a member of the space industry, okay? That can come in the form of somebody who's really good with admin skills. Maybe they don't know anything about engineering, but they're very good at computer programming. That would be amazing because of how we're tying together teams. That's a difficult question, Hugo, because really the space industry has a spot that reflects everybody's passions. But the important thing is to be passionate. Get good at what you do. Understand it'll take a few years. In my case, a time in the U.S. Air Force made a lot of sense. I was able to get through the Air Force, finished my bachelor's degree, got into a fantastic master's program with Johns Hopkins Applied Physics Lab. And that really was possible because of how, I had planned out my path. My path is mine. Your path is yours, and your listener's path is theirs. Really, it's where you feel the spirit, where you draw your source of inspiration from the well, if you will. When you go inside and you're looking to go to the wellspring of who you are as a person, what drives you, you go down there, you pick up the water. What does that water taste like? What memories does that give you? How does that tie to your formative experiences? And I would say go to where that leads. And if you do that, you'll find a space for you in this industry and elsewhere in deep tech. Right now, we're about to enter truly the age of wonders, especially, again, with all the things that artificial intelligence will be enabling us.
Can you speak a bit more about the impact of AI? I know this is a passion area for you.
Absolutely. Well, I am not by any means a P-doomer. However, it's important to understand that we need to maintain alignment with our systems. Right now, we're in a complete mad race to who can produce the first AGI. I think many of these people are almost scared of what they are unleashing. That should say something, because what we are now going to explore and experience really is uncharted waters. Ray Kurzweil called it the technological singularity. People may have heard that term. It's evidenced by what he called the law of accelerating returns. Now, I'm sure everybody's familiar with Moore's law. Price performance of a chip doubles every 24 months, which means that not only are things getting faster, they're getting smaller. When you extrapolate that on a trend line, it's not logarithmic, it's exponential. And if you look at where artificial intelligence has been trending over these past few years, we are on an exponential uptick. Now, what is the singularity in regards to that? It's where for at least a brief period of time, that sigmoid curve goes completely vertical and nobody can predict what's on the other side of that. And that could be an opportunity. That could also be extremely dangerous. We're all familiar and bred on pop culture, so we've all seen Terminator and The Matrix. Science fiction's, I think, social responsibility is to explore the art of the possible. And it's important that we take those lessons and we learn it in that creative space where we're trying these ideas on, seeing how they're fitting, and seeing whether or not they should be explored. So really, science fiction has given us two options. We either go second renaissance like The Matrix, or we go Butlerian jihad like Doom. I think most people would probably prefer something in the middle, technology being utilized for the greater good of humanity to solve the major problems facing us like scarcity, health. We're seeing trend lines in aging right now. That could be very exciting. Since the base pairs of DNA are just GATCA, if I'm not mistaken, or GATC. What that means is that now people are exploring that in a large language model. And we're finding interesting relationships that no human researcher is able to identify due to the complexity of those relationships. But a computer that's ontologically mapping that in some virtual space is able to perceive and more or less parse through relationships on the genomic level that we just can't understand. And now we have, of course, if you remember a few years ago, protein at home, where they were doing protein folding. All this data is now compounding on itself, meaning expect, if not this year, the next year, new breakthroughs in medicine, which are being explored through artificial intelligence. So there's a promise there, but here's a danger. I think we've all seen what's happening in the Ukraine. Imagine if you had a swarm of those autonomously operating. This could be a very, very interesting and dangerous world. So it's everybody's problem now. If we're relying on a few thought leaders to make the decision for you, I think that's a huge mistake. This is something that affects everybody. We do live in a democracy, but a democracy really does extend beyond just politics. A democracy is the choices that you make at, say, the supermarket. Your democracy is where you choose to spend your tax dollars. Your democracy is where you choose to use your large language model on your computer, whether you're going with a Chat GPT, a Grok, a Claude, a DeepSeek, etc. The choices we make impact the greater system. This isn't just about where your tax dollars are being spent anymore. This is about the practical safety and existential security of yourself, your family, and your community. It's not a light issue by any stretch, Hugo. Right now, we are in probably the most unprecedented time in the 4.5 billion years of evolution of life on this planet. We're creating a new kingdom of life, the digital. And, where that might lead is anybody's guess. And that's kind of the risk.
Exciting and a little scary.
It should be. It should be a sobering, and it's everybody's responsibility, Hugo.
So I think in conclusion here, we normally do a lightning round. So rapid fire questions, whatever first comes to mind is a short answer. So what's the first thing you check on your phone every morning?
What's the first thing I check on my phone each morning? Typically, I'll pop on X, check the latest tech news. I also get the space industry updates. Payloads a great one.
Very interesting. If you could have dinner with any astronaut, past or present, who would it be?
Everybody would love to see Buzz Aldrin. I'd like to see him again. I had a brief interaction with him back in 2016 where he sat down and took a look at a project we were working on dealing with heavy ocean launch rockets. We were effectively trying to do Bob Truax's Sea Dragon super heavy lifter. We are talking about steel Starship-sized vehicles back in 2014, 2015 through this Norwegian startup I was working with. Well, we were at Spacecom in 2016 and had an opportunity to spend some time with Buzz, where he told me quite clearly that we should be focusing and dedicating our time to building cycler networks. We then moved to talking about how we need to build the transcontinental railroad for the inner and outer solar system through cycler networks. So I would like to have dinner with Buzz and finish that conversation.
If you could have one piece of sci-fi tech that you could create today, what would it be?
Interestingly enough, this question might be completely obsolete in 3 to 5 months with how quickly sci-fi technology is being adopted. But if I could have one holy grail sci-fi technology, faster than light travel, why not? I'm a bit of a skeptic as to whether or not that's even possible, so let's go ahead and get that one, because we might not be able to get it any other way.
What is your favorite AI platform?
Well, I haven't tried out Grok 4 Heavy yet. I'm a huge fan, of course, of ChatGPT Pro. My favorite AI platform would probably be the one that we are quietly developing for ourselves. A colleague of mine actually met him when I was stationed in Japan while we were both dealing with the Fukushima earthquake and the nuclear reactor that followed. Nick and I have been working for a number of years on something called Project Shepherdess. Can't say any more than that. We'll just leave it at that.
Intriguing. If you had to call out one movie or a book that you think gets it reasonably right in terms of predicting the future, what would you name?
I hope The Culture, but I'm afraid it's going to be Warhammer if we're not careful.
Finally, what is one thing that most people misunderstand about working in space?
So here's the major one that I've seen. Oftentimes, you underestimate the challenge. We find that it's not the known unknowns that get you, it's the unknown unknowns, not to paraphrase Donald Rumsfeld. If you read the full quote, it actually does almost make sense. But really, it's about the things that you don't know, which are the things that get you. And we've seen that, at least in this industry, that's often been written in blood, unfortunately, both of flight crews and ground personnel. It's the things you don't know you're missing, which oftentimes pose the greatest risk. Imagine that you are in terra incognita on a new map that you do not have any bearing on, and it's up to you to write that map as you're traveling. Oftentimes, the frontier was very deadly for a reason, and when it comes to the space industry, we really are all on the frontier, and therefore there are frontier risks associated with that. And many of those, again, are the ones that you do not expect, which is why it's important that you build a great team of advisors around you. We're lucky enough to have that, whether it's former International Space Station commanders and astronauts to launch directors. Mike Leinbach, for example, was one of the lead Columbia investigators. A fantastic book, his biography, Bringing Columbia Home, details exactly what NASA experienced during that time. And it's about having the right people by your side as you're exploring terra incognita, which could be the difference between life and death.
Well, Christopher, thank you so much. This has been a broad-ranging and a very stimulating and a visionary conversation. Really appreciate the time. I wish you and Blackstar Orbital every success for the future.
Thank you very much, Hugo. It's been great. Have an excellent one, and please have me on again sometime.
That wraps up today's episode with Christopher Jannette, CEO of Blackstar Orbital. From satellite reusability to AI-powered space infrastructure and new frontiers in payload delivery, it's clear that the next decade in aerospace will be as much about innovation here on Earth as it is about what happens beyond it. If you want to learn more about Blackstar Orbital and their groundbreaking work, head over to blackstarorbital.com or connect with Christopher on LinkedIn. And to our listeners, thank you as always for tuning in. If you enjoyed this episode, subscribe, share, and drop us a review. And if you're ready to future-proof your business or your career, don't forget to check us out at resettingtomorrow.com. Until next time, stay curious, stay inspired, and keep resetting tomorrow. This is Hugo Malan signing off. See you in the future.
This podcast was produced in partnership with Amaze Media Labs.